Hi, in this video we're going to introduce you to the concept of congruent figures, and congruent polygons, and most specifically congruent triangles. We'll show you what it means for the corresponding parts of the congruent triangles and how those fit together. We'll also introduce you to what it means to be an included angle or an included side. Two very important concepts if you're going to apply the angle-side angle postulate and the side angle side postulate. Two postulates that this video will introduce you to as well. And finally, we'll teach you a third postulate called the side-side-side postulate. Now we're going to use all of the theorems and definitions that we've picked up in Chapter 1 and Chapter 2. And now, here in Chapter 3, we're going to use them to prove things that are not clearly as self-evident. In Chapter 2, I'll admit, sometimes you could just look at a picture and tell something was true. Well, in Chapter 3, there's going to be a little more work involved, and I think you're going to like it. In fact, as the proofs get a little more complicated, most students have an easier time understanding how to do them. And I know that sounds counterintuitive, but it really is the way it works. So, thanks for watching. I hope this helps, and we'll see you tomorrow in class. What does it mean for figures to be congruent? Any kind of figures can be congruent. So you could have congruent rectangles and congruent circles. You could have congruent pentagons or congruent decagons. For most of this semester, we're going to be dealing with congruent triangles. So let's use those as our examples. If I tell you, or you're given, that triangle ABC is congruent to triangle XYZ, what does that mean? Well, it means that no matter how you change one, the other figure will remain congruent to it. And that means that the corresponding sides will all have the same length. So here you can see AB is congruent in length to XY, BC to YZ, AC to XZ. No matter how I manipulate one triangle, since they're congruent triangles, the lengths, the corresponding sides' lengths remain the same. Now let's take a look about the angles. You can see that that's true as well. The corresponding angles have measures that stay the same no matter how I manipulate and change the triangles. That's really what it means to be congruent. If I were to lay one triangle on top of the other, it would fit perfectly. All the corresponding side lengths are equal, and all the corresponding angle measures are also equal. And this brings us to our definition of congruent polygons. Congruent polygons, or in this case triangles, are two or more polygons in which all pairs of corresponding parts are congruent. And when we say corresponding parts, we're referring to the sides corresponding to each other and the angles corresponding to each other. The definition of congruence is not one that we need to memorize for our proofs, but there is something that we will need to remember from this section, and that's the reflexive property. Let me show you how it works. Suppose you were given that triangle ABC on the left is congruent to triangle ADC over here on the right. Well, the congruencies among the sides would be that AB is congruent to AD, the longer side BC is congruent to this longer side DC, and then the side down the middle is a side of both triangles. So, believe it or not, we would say that AC is congruent to AC, and we'd use the reflexive property. The reflexive property means that any segment or angle is congruent to itself. Now, I know that's very obvious, but believe it or not, it is something that you'll be making note of as you work your proofs in this chapter. Alright, this next section of the video deals with proving congruent triangles. Now we know what they are. They're two triangles whose corresponding sides are congruent and whose corresponding angles are congruent. But how do we prove it? How do we show? Well, there are several different theorems or postulates to do so. But tonight, I want you to use an app that we talked about in class called Sketch Exchange. And I'll show you how to do it now. And I want you to try working with a Geometer Sketchpad sketch that's available under my name on the Sketch Exchange, and see if you can figure out for yourself which sketches work, or I'm sorry, which combination of sides and angles work, and which ones will produce more than one triangle that suits the conditions. So let me walk you through how to get onto the sketch, and then we'll talk a little bit about how it works. The first thing you need to do is to go to the Sketch Explorer app, which I told you to download in one of the posts last week. As you can see, it's this app right here in the middle, Sketch Explorer. Once you've opened the app, press the icon that looks like a book down in the lower right-hand corner. That will take you to Sketchpad Explorer's Sketch Exchange. It's an online community of teachers that have uploaded Geometer Sketchpad sketches. If you go to the last bulleted line of text where it says Homepage, press that, and it'll take you to another page where you can search for McNulty, and you'll find the sketch that we need to open. That sketch is called Triangle Congruence, and it should look something like this. Okay, this sketch gives you several different combinations of sides and angles, and it asks you, knowing that each combination of angles or sides in one triangle were congruent to the sides or angles of the other triangle, would the triangles have to be congruent? Well, let's start off with the first one on the right, angle, angle, angle. In this situation, we're not told that any of the sides of the two triangles are congruent, but all three of their angles are. And as you can see, I can manipulate point E, and while the side lengths change, the angle measures stay the same. If I manipulate point F, the whole triangle moves, and if I manipulate point D, once again the angles move. So the question becomes, can I move the triangle on the right and maintain the angle measures, but create a triangle that is not congruent to the given triangle ABC? And the answer is yes. Therefore, angle, angle, angle is not a means of proving triangles congruent. Now, I would like you to pause the video and check out the other 6 possibilities. Side, 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 angle, etc. to determine whether or not those combinations of sides or angles is a way to prove that triangles are congruent. If there's no way that you can manipulate the triangle on the right and have it be a different size than the triangle on the left, then it is a way to prove triangles congruent. So I'd like you to pause the video, go into the app, open up the Triangle Congruence sketch under McNulty, and press each one of these buttons on the sketch and try to manipulate the sketch to see if it works. When you're done with all 6, come on back to the video and we'll go through some of the theorems that you have to memorize. Okay, we've seen that if 2 triangles are congruent, that we get a lot of congruent things. For instance, if I know that triangle ABC is congruent to triangle XYZ, then I know that the 3 pairs of sides, corresponding sides, are congruent, and the 3 pairs of corresponding angles are congruent. But the question is then, do I need to know that all 3 of the sides and all 3 of the angles are congruent before proving that the triangles are congruent? And the answer is no. Hopefully, when you explored that sketch on the app, you were able to find out that some of the combinations didn't work, and some of them did. Today we're going to explore 3 theorems which our book presents as postulates that are going to be the way that we prove triangles congruent from now really until chapter 7. The first of these is called side angle side. Side angle side says if 2 sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. All right, well, what do they mean by the two sides and the included angle? Well, it means this. Suppose that you were given just that AB was congruent to XY and that BC was congruent to YZ. Oops, not that. Now, those would be the two sides, but the angle would have to be the angle that's between the two sides. So in this case, it's angle B because that's between the two congruent sides, and angle Y. Now, you could work with a different set of sides, but it has to be the angle that's between them in order to prove the congruency. Okay? Let's take a look at another one. Suppose now we are given that two angles of one triangle and the included side were congruent to two angles and the included side of a second triangle. If that were the case, then the two triangles would be congruent by angle, side, angle. This time it's the side that has to be between the two angles, so it becomes the included side. And if you have a situation like this where you have two angles and the side between them, then the triangles are congruent by angle, side, angle. All right, let's take a look at the last situation that we're going to work with for this semester called side, side, side. This may be the easiest one to understand of all. If the three sides of one triangle are congruent to the three sides of the other, then the triangles are congruent. So in other words, if you knew that AB was congruent to XY, and you knew AC was congruent to XZ, and you knew that BC was congruent to YZ, well, then you'd know that the two triangles were congruent by side, side, side. You need to memorize not the entire theorem, but just the abbreviation SAS, ASA, and SSS. And be sure to use the right one given the right information. Okay, that's all for this video. There's a lot of material in here, so I hope you took good notes and you want to make a card for each one of these three postulates that we're going to be using this theorem. We'll be using this semester.